Okay, good afternoon, students. So I am Dr.R.Poornima, Department of Mathematics. So I am going to handle your GATE Maths coaching. Okay, I am just giving some idea about that aptitude questions. Okay, which helps to solve the questions within a quick manner. Okay. 30 into 50 into 300. 50 into 300. 50 into 300. So only few students have joined. Trainers మొత్తం 3 trainers. మొత్తం 3 trainers 3 into 3000 కుట్టలమ్మా వాళ్ళకి 2000 ట్రాన్స్పోర్టేషన్ చార్జ్ ఎక్స్ట్రా పడుతుంది ట్రాన్స్పోర్టేషన్ నేను అవ్వదు సరే అప్పుడు 5000 ఆల్ టైప్ ఆఫ్ ట్రైనర్స్ So linear algebra. First, today we are just going to discuss about the linear algebra. The topics which are determinants, inverse of your matrix, rank of your matrix, homogeneous and non-homogeneous linear equation, eigenvalues and eigenvectors, Cayley-Hamilton theorem. Okay. So the textbook we just referred as AR versus star. The determinant concept, actually the properties of determinants. So value of the determinant will not be changed if rows and columns are interchanged. Okay, that is determinant A which is equal to determinant A transpose. So example, determinant A is equal to 5, 4. First row it is 5, 4, second row it is 1, 2. Okay, then you just normal calculation 5 into 2 no. So 5 into 2 it is 10 minus 1 into 4. Like that you are just finding the calculation part, okay, of the determinant. So 10 minus 4 it is 6. Then A transpose we have to interchange the rows and columns. Okay, so 5 we are just changing that first column 5 1 as a first row, then second column 4 2 as second row 4 2. Then A transpose will be 5 1 4 2. Then you are finding the determinant for this part. Same calculation, it is 5 into 2 my 10 minus 1 into 4 it is 4. So 10 minus 4 it is 6. So determinant A is equal to determinant of A transpose. The next will be value of the determinant is multiplied by minus 1 if two rows and two columns are interchanged. Okay. That is example. First, we just consider that A matrix, it is 1, 2, 3, 4. Then determinant of A will be 1 into 4, 4 minus 3 into 2, it is 6. So 4 minus 6, it is minus 2. Then determinant of A, we are just changing that one, 3, 4, 1, 2. Okay. So 6 minus 4, it is plus 2. So if you are changing the rows, you will be getting that negative sign. You are multiplying by negative sign. Then value of the determinant can be 0. So the value of the determinant can be 0 in the following cases. So the elements in two rows or two columns are identical. That is example, determinant A, that is 1, 2, 3. The first row and the third row, 1, 2, 3, the same, no? So that means you will be getting the value of the determinant is 0. So the elements in two rows or two columns are identical, then the value of the determinant will be 0. The next one, the elements in two rows or two columns are proportional. That is 1, 2, 3. Then here it is actually 3, 6, 9. Okay, the first row it is 1, 2, 3. The second row it is actually we are multiplying by 3 by first row. It is proportional. Okay, 3 into 1, 2 into 3 is 6, 3 into 3 is 9, which are proportional. Then the value of the determinant will be 0 only. Then all elements in a row or column are zeros. That is determinant A is equal to 1, 2, 3. Then second row fully 0. Then also the value of the determinant is 0. So the elements in the determinant are of consecutive order, that is continuous order. Then it will be valid for 3 by 3 and higher order matrix. Okay, determinant A is 1, 2, 3, 4, 5, 6 and 7, 8, 9. The determinant is 0. So we can start first element from any number. Okay. So then the determinant of upper triangular, lower triangular, diagonal, scalar, identity matrix is the product of its diagonal elements. So the determinant of upper triangular, lower triangular matrix, then diagonal matrix in the scalar matrix, identity matrix is the product of its diagonal elements. So if it is an upper triangular matrix, then determinant A it is 1, 2, 3. So this is called your upper triangular matrix. In the upper triangular alone, you will be having values. Okay. So we are expanding by using normal evaluation of the determinant process. We will be getting 1 into minus 4 into 7. Okay. That is, we are multiplying the diagonal elements. Okay. So this is the diagonal elements, no? We are multiplying only the diagonal elements. 1 into minus 4 into 7, that is minus 28. So for the upper triangular matrix, you should multiply the diagonal elements alone. That is the determinant value. Then for the lower triangular matrix, you can follow the same steps. Okay, you multiplied only the diagonal elements. That is 1 into 3 into 7, that is 21. Then diagonal matrix, the same manner. You multiply the diagonal elements 3 into 2 into 5, that is the determinant value, it is 30. So a matrix is diagonal if and only if at least one diagonal element should be non-zero and all other non-diagonal elements should be zero. Okay, that is called the diagonal matrix. So the next one it is scalar matrix. So determinant A, that is 3, 0, 0. Scalar matrix means it's like a same diagonal matrix, but the constants will be same. The constants in the diagonal matrix will remains the same. Okay, that is called your scalar matrix. Then you multiply only the diagonal elements, 3 into 3 into 3, you will be getting 27. So the diagonal elements should be same. The non-diagonal elements should be 0. Okay. Then it is identity matrix. So determinant I, that is 1, 0, 0. This is a 3 by 3 identity matrix. 1, 0, 0, 0, 1, 0, and 0, 0, 1, which is equal to, you multiply the same diagonal elements, you will be getting the answer. That is of your determinant value, which is 1. The next one, if A is an m by m matrix, then determinant of Ka, you just remember this rule. Okay, determinant of Ka means it will be K to the power n into determinant A. So where n is the order of the matrix A. For example, determinant A is equal to 2 by 2 matrix, we just consider as 1, 2, the second row is 3, 4. Then you evaluate that by using your determinant process. So 1 into 4, it is 4, minus 2 into 3, it is 6. So 4 minus 6, it is minus 2. Then you should multiply the determinant by 3. That means 3 into determinant A, which is equal to, you can apply this property, K power n into determinant A, no? So 3 square into determinant A, which is equal to 9 into, the value of the determinant is minus 2. So you just replace that value, 9 into minus 2, it will be minus 18. Okay. The next one, if each element of a row or column contains sum of two elements, then the determinant can be expressed as the sum of two determinants of same order. So I'm repeating, if each element of a row or column contains sum of two elements, then the determinant can be expressed as the sum of two determinants of same order. So here is an example. Determinant A, which is equal to 1, 2, 3 is the first column. Then 1 square, 2 square, 3 square is the second column. Then 1 square plus 1, 2 square, 2 cube plus 4, then 3 cube plus 5. So we just split the determinant by 1, 2, 3, first column. Then second column will be 1 square, 2 square, 3 square. The third column, you just consider the first part of your determinant. That is 1 cube, 2 cube, 3 cube. The second, you put common addition. Then 1, 2, 3, the first column. Then 1 square, 2 square, 3 square, the second column. Then the remaining, you just consider that after that addition term, 1, 4, 5. Okay. So next, consider the matrix A. Actually, you are writing your general matrix A11, A12, A13, A21, A22, A23. These are all the positions of your matrix, or just simply we are calling entries of the matrix. Okay, then A31, A32, A33. So the method, if they ask to find your determinant of A, for that 3 by 3 matrix means normally we are just finding that method, no, A11 into A22 multiplied by A33, okay, minus A32 multiplied by A23. Okay, like that we are expanding. This is called a method 1. It is normal calculation part. The method 2, first you just write A13 and A33 position. Okay, so here consider the matrix form A13 and A33. The last two values you just write A11 and A31. So in between you write the matrix A11, A21, A31, then A12, A22, A32. I am just telling in column wise. Then A13, A23, A33. Then you just find that product term. You like that. Okay. So you multiplied all these terms. That is A13 into A21 into A32 plus the next product of these terms A11 into A22 into A33 plus A12 into A23 into A31. Okay. Then in the reverse order minus this way A33 into A21 into A12. Okay. Minus A31 into A22 into A13 minus A32 into A23 into A11. Okay. So these are all the terms. So after simplifying these terms, you will be getting one finite value. No, that is the determinant value of that particular matrix. Okay. So if the matrix is of order 3 by 3 means you should follow that method too. So if determinant contains more number of zeros, then you can use method 1. Okay. Next, we are going to see one example for finding the determinant of a 3 by 3 matrix. So in A matrix, it is given first row 1, 2, 2, then second row 2, 1, 2, and third row 2, 2, 1. Okay. First, you just write A13 and A31's position. That is 2, 1. We have written here. Next, in the last way, just write that A11 position and A31's position. It is 1, 2. Okay, we have written. In between, you write the matrix terms. So 1, 2, 2, 2, 1, 2, then 2, 2, 1. Okay, now you multiply the terms this way 2 into 2 into 2 plus 1 into 1 into 1 plus 2 into 2 into 2. Okay, so 2 into 2 into 2 will be getting 8 plus 1 into 1 into 1 will be getting plus 1 plus 2 into 2 into 2 again 8. Then reverse order minus 1 into 2 into 2. Okay, that is 4. So minus 4 minus 2 into 1 into 2. Okay, minus again 2 into 2 into 1. Okay, so we'll be getting minus 4, minus 4, minus 4. So the determinant value, it is 5. Okay, this is the shortcut way to find the determinant of your 3 by 3 matrix. Okay, next. In a similar way, you try this matrix also. Example 2, it is A 5020. It is if your matrix having more number of zeros means you can use the normal first method. You will be getting the answer. Okay, next. The following represents equation of a straight line. So you'll be getting x24 y80111 which is equal to 0. So the line passes through. You have to select the option. Okay, this is the gate exam question. So now you just apply the same concept. Okay, first you write 4, 1. Then the last two terms you write x1. In between you write that you multiply. After that you will be getting x into 8 minus 2 into y plus 4 into y minus 8. Okay, we just form it as an equation form because which is equal to 0 which is given in the question itself. Okay, you just write put it equal to 0. Then you expand the term 8x minus 2y. You multiply like that my plus 4y minus 4 into 8. Okay, so you'll be getting minus 32 which is equal to 0. So you keep xy terms alone in the left hand side. So 8x, then minus 2y plus 4y, you'll be getting plus 2y. So 8x plus 2y, which is equal to 32. Therefore, 4x plus y, we are dividing by 2. 4x plus y, which is equal to 16. Okay. Then you just replace the point of x and y. Okay. You'll be getting 16, no? So 4 into 3 it is 12 plus 4 it is 16. So that you will be considering x is equal to 3 and y is equal to 4. So you can select the option B. That is your correct answer. Okay. So yeah, you know the step method 2 of your finding the determinant of 3 by 3 matrix. No, you are applying the same thing and you are just keeping that unknown terms in one side. You just give some values of x and y to get that exact point which passes through the line. Okay, the next. So we just consider the 4 by 4 matrix. It is a general matrix of 4 by 4. It is A11, A12, A13, A14, then A21, A22, A23, A24. The third row A31, A32, A33, A34. And fourth row A41, A42, A43, A44. It is a 4 by 4 matrix. Okay. So the method 1 is a normal procedure. You have already studied. No, it is a complicated one. So if you are preferring that method 2, you just apply the steps. That is step 1. Among the given element of your matrix, select any non-zero element. Okay. Then step 2, make all elements above and below or left and right of the selected element as zero using row and column operations. Okay, so you just use the row and column operations to make the elements below, above, and left and right to be zero. Okay, so therefore the matrix will be getting in the form A is equal to A11, that is a new term. Okay, that's why we're just putting plus. Then the remaining terms of the first column will be 0, 0, 0. Then the remaining terms of the next columns. So the first column has more number of zeros. Okay, you can see the first column, it will be having more number of zeros. So the determinant along the first column, that is determinant A equal to A11 into, so we are just expanding A11 into the 3 by 3 matrix. Okay, then you know the procedure of expanding or finding the determinant value of a 3 by 3 matrix. No, you can apply that one. You will be getting the determinant value of your 4 by 4 matrix now. Okay, now we are going to see one example. So find the determinant of the first row, it is 1 minus 1 0 1. Second row 1 2 3 4. Third row it is 2 3 4 9. Fourth row will be 0 1 0 2. So now we are just selecting one non-zero element. Okay, by default you always consider the A11 position term. So if it is a non-zero element means you can select that one. Then you can use the row operations and column operations to make the remaining elements to be zero. Now we just apply two row operations. R2 goes to R2 minus R1 and R3 goes to R3 minus 2R1. So that you will be getting the first column, that is 1, the remaining terms of your first column will be 0. Okay, so you expand by using your first column 1 into, you consider the 3 by 3 matrix. Then you know how to find the determinant of your 3 by 3 matrix. By already we just discussed the procedure. We are going to apply that one so that you will be getting the determinant value of your 4 by 4 matrix. Okay. Next, the next problem. If A has m rows and m plus 5 columns and B has n rows and 11 minus n columns, the order of A and B if A, B and BA are defined. Okay, that is the question. So first A, the order of the matrix we should write m by m plus 5. Similarly, the B matrix, the order of the matrix should be n by m 11 minus n. So you know already the properties of the matrices, no? So if it is the first columns, that is m into n, number of rows and number of columns, the first column's column matrix should be equal to the second column's row. So by applying that one, you will be getting m plus 5 equal to n. Okay. Similarly, the next two matrices which is given order, no, b of n into, we just write it in the order of BA because in the question they will be asking AB and BA. So we just write the B matrix first, then the A matrix. Then we should equate the columns of the first matrix to be equivalent to the rows of number of rows of the second matrix. So you will be getting 11 minus n equal to m. Okay. Now we just solving both the equations to get the values of m and n. Okay, normal solving method. So therefore the order of the matrix of A is m by n, then B it is n by m. Okay, so 3 comma 8 and 8 comma 3 respectively. This is the answer of this one. The next, if A is equal to Aij of m by n matrix, they will be giving a general matrix such that Aij is equal to I plus j for all ij, then sum of all element of A is, what is that? That is the question. So A matrix means Aij of m by n order. So Aij just I plus j, which is given, no, I plus j for all I and j. So A11, actually, what is your I1j here? A11 is the position, means you will be taking I is equal to 1 and j is equal to 1. So like that you will be taking, no. So first entry for A11, it is 1 plus 1. Second entry actually A12, right? So A12 means 1 plus 2. Third entry will be A13, okay? That means 1 plus 3. Like that you are defining your general matrix up to uh, n columns and m rows, no? So you just define like that. Okay, that they will be asking the general form of your A matrix, we define, that is the solution. So according to that one, you separate that one, 1, 2, 3, 4, etc. Then you are combining that matrices. That is, you are already studied that the combination of addition or subtraction within the matrices means we can split that, no? So we are just splitting the terms. Okay. So after adding that one, you will be getting the first matrix of the form 1, 2, 3, etc. up to 1, 2, 3 to m number of terms. Then the last one, it is the second alone we are expanding. So 1, 1, 1, this alone. 1, 1, 1, 1, etc. Then second column will be 2, 2, 2, 2, etc. Then third column will be 3, 3, 3, 3, etc. The last column will be n, 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 etc. So that you will be getting m into m plus 1 by 2, m into m plus 1 by 2, etc. The terms. Okay, we are expanding the number for n columns, no? So n dot m into m plus 1 by 2. Similarly, for m rows means m dot n into n plus 1 by 2. You can apply that property, then you can add both. Okay, so that you will be getting mn by 2 into m plus 1 plus n plus 1. So which is mn by 2 into m plus n. You are combining this m and n, then 1 plus 1, it is 2. Next problem. If A is Aij of 3 by 3 matrix, B is Bij of 3 by 3 matrix such that Bij is 2 to the power I plus j. So Aij for all I and j, then determinant A is 2, determinant B. They will be asking the question. So the choices they have given. So first you just write the determinant A. You will be considering a 3 by 3 general matrix. So A11, A12, A13, second row A21, A22, A23, and third row A31, A32, A33. Okay. Next, determinant B, it is given 2 to the power I plus j into Aij. So the Bij can be defined 2 to the power I plus j into Aij. That means A11 means 2 to the power 1 plus 1 into A11. That is the first entry of your Bij matrix B. Okay. Similarly, the second terms, you will be getting 2 to the power 1 plus 2. So 2 cube into A12. Next it is 1, 3, no? So 2 to the power 1 plus 3, 2 to the power 4 into A13. Like that, we are just defining our second row and third row. Then you take that common terms as an outside the matrix determinant value. Okay, because it is a scalar matrix means we can take it as a common constant terms outside the determinant. We are applying that concept. So 2 square, 2 cube and 2 power 4 can be taken outside. So remaining the entries inside the determinant will be A11, 2 A12 and 2 square A13. Similarly, for the second row, A21, 2 A22, 2 square A23. Similarly, the third row will be A31, 2 A32 and 2 square A33. Okay. So again, you just take it as that from the second column, you consider your 2 term. Then the third column, from the third column, you can take it out 2 square term. Okay, so you combine the all 2 to the power terms. So you will be getting 2 to the power 13, I think. Yeah, you will be getting 2 to the power 13, the final answer. So the next problem, if A is Aij of n by n such that Aij is I square minus j square for all I and j, and subdivision to Aij is I minus j for all I and j. Find the sum of all elements of A. That is our question. So first you have to define A matrix. It is Aij n by n. The first subdivision of Aij will be I square minus j square. That is in the A11 position. A11 position, I is 1, j is 1. So I square minus j square means 1 square minus 1 square, it is 0. Okay. The next position actually A12. Okay. So 1 square minus 2 square. That is 1 minus 4, it is minus 3. Then third term, it is A13 position. So 1 square minus 3 square, it will be minus 8. Okay. Like that, you have to write your general term 1 square minus n square. Similarly, the other values too. Okay. So you just find all the remaining rows of this one. Okay. So that you will be getting your A matrix. These are all the elements of your required A matrix. Next. A is a skew symmetric matrix means in skew symmetric matrix, all diagonal elements must be 0 and the non-diagonal elements should be a real number. Okay. So in a skew symmetric matrix, all diagonal elements must be 0 and the non-diagonal elements should be a real number. So when sum of all elements of skew symmetric matrix is always 0. This is the advantage of this one. Sum of all elements of a skew symmetric matrix is always 0. For example, A it is 0 minus 3, 3 is 0. It is a 2 by 2 matrix. So sum of all the elements of this skew symmetric matrix, it is 0 plus minus 3 plus 3 plus 0. So it is 0. Similarly, for the second 3 by 3 matrix, you can add all the elements, okay, so that your sum is 0. So if I throw jth column term of a matrix is in the form Aij is equal to I power n minus j power n, where n greater than 0, then corresponding matrix is always a skew symmetric matrix. So if I throw jth column element of a matrix is in the form Aij is equal to I power n minus j power n, where n greater than 0, then the corresponding matrix is always a skew symmetric matrix. Next, a note, a matrix A is said to be symmetric if A transpose into A or Aij is equal to Aji. Okay, this is the note we have to know. A matrix A is said to be symmetric if A transpose equal to A. Then a matrix A is said to be skew symmetric if A transpose equal to minus A or Aij is equal to minus Aji. Okay, so the value of the determinant they will be asking for question. So 1 plus B, B1, second row B1 plus B1 and third row 1 2b1. So you just apply this column operation. C1 goes to C1 plus C2. Okay. So that your first column will be 1 plus 2b, 1 plus 2b, 1 plus 2b. Then second and third column remains the same. That is b 1 plus b 2b 1 1 1. Okay, which is equal to. You will be taking that 1 plus 2b from the first column outside. So that remaining terms it is 1 1 1. If any two rows or columns are identical, the value of the determinant will be 0. No, so as per the property, the value of the determinant is 0. Next, find the element of 1 by A, B, C. Second row 1 by B, B, C, A. The third row 1 by C, C, A, B. So first, instead of 1 by A, you can write BC by ABC. That means your BC and BC get cancelled. Remaining you will be getting 1 by A. Okay. So in a similar way, we are writing. That is, we are representing 1 by B and 1 by C in another way. So 1 by B can be represented by CA by ABC. Similarly, 1 by C can be represented by AB by ABC. The remaining two columns, you just write as it is. Now, you from the first column, you can take 1 by ABC outside. So, you will be getting BC, CA, AB as your first column. You compare first column with third column. Okay. So, both are same. So, the value of the determinant is 0. So, the next. Find the value of the determinant. This is a 4 by 4 matrix determinants. The first row it is x a a a, then similarly a x a a, then a x a, then a x. Okay, so you apply that row column operation. C1 goes to C1 plus C2 plus C3 plus C4. Okay, so the first column will be x plus 3a, x plus 3a, x plus 3a, x plus 3 in the same manner. Okay, you just take it as x plus 3 as a common term. So you will be getting 1 1 1 inside your determinant of your first column. Then you can apply the row operations. R2 goes to R2 minus R1. The similar way R3 goes to R3 minus R1. Then R4 goes to R4 minus R1. That is, you just make it as that elements, more number of elements in the first column to be 0. Okay, so you can expand with your first row term. So 1 into this matrix, 3 by 3 matrix. Okay, then you know how to define the determinant value of your 3 by 3 matrix. No, so you just apply that concept, or here that value you just multiply the diagonal elements alone, x minus a into x minus a into x minus a. So you will be getting the answer. Then shortcut method, if the diagonal elements are one category of same elements and non-diagonal elements are other category of same elements. So the next, so you can select the first row. Okay, just add the elements of your first row. Take the product of first second, first third, and first fourth. Then you multiply that steps of 3 and 4. Okay, so determinant a is equal to, for example, x a. This is actually the other procedure. Okay, you can follow the same first procedure. It is only easy to you. The next, the value of a is, it is given first row 1 plus x 2 3 4. Second row it is 1 2 plus x 3 4. Third row 1 2 3 plus x 4. Then fourth row it is 1 2 3 4 plus x. Then determinant a, they ask to find. No, so you just add the first row terms. Okay, so you'll be getting x plus 10. Then you can take x plus 10 outside. Then apply that R2 minus, R2 goes to R2 minus R1, R3 goes to R3 minus R1, and R4 goes to R4 minus R1. Same procedure. Okay, then it is an, check that whether it is an upper triangular matrix. Yeah, it will be your upper triangular matrix. So you multiply the diagonal elements, x into x into x. Okay, so x plus 10 into x into x into x. So you will be getting x cube into some x plus 10. That is your answer. Next problem, 4 by 4 matrix. First row 1 plus a, b, c, d. Second row a, 1 plus b, c, d. Then third row a, b, 1 plus c, d. And fourth row a, b, c, 1 plus d. Okay, you can apply that column operation. C1 goes to C1 plus C2 plus C3 plus C4. So you'll be getting one first column, that is 1 plus a plus b plus c plus d. No, you can take it outside because all the column, first column will be having the same entry. No, you can take it outside. So next, after taking outside that one, the first column will be 1 1 1. You can apply the same row operations. R2 goes to R2 minus R1, R3 goes to R3 minus R1, and R4 goes to R4 minus R1. Okay, so maximum number of zeros in your first column. So you expand by using your first column term, so that you will be getting your answer. It is an easy way. Next, find the value of, this is a 3 by 3 matrix, 1 1 1 a b c, a square b square c square. So you just apply the column operation. C2 goes to C2 minus C1, and C3 goes to C3 minus C1. So A matrix, it is, after applying that operations, you will be getting first row is 1 0 0, then A, B minus A, C minus A, and A square, B square minus A square, and C square minus A square. So that you will be getting just a normal expansion, because we base first row. your first row is having more number of zeros, no? So you expand by using your first row, then you will be getting the terms like that. Then b minus a into c square minus a square. So c square minus a square is in the form of a square minus b square. That is a plus b into a minus b formula, no? So c square minus a square can be written as c plus a into c minus b. In a similar way, b square minus a square, you just write b plus a into b minus a. Okay. So b minus a into c minus a within brackets. We are taking that b minus a into c minus a as a common term from the first two. Okay, b minus a into c minus a, we are taking outside. So inside the bracket, you will be getting c plus a minus of uh, b plus a, that is minus b minus a. Okay, so c plus a minus b minus a. This minus a and plus a get cancelled, so you will be getting c minus b. Okay, so this b minus a can be written as minus of a minus b. So a minus b into c minus a into c minus b can be written as minus of b minus c. Okay, so again you just c minus a, keep it as it is. So a minus b into b minus c into c minus a. Okay, this is the answer. Now the next one. For 2 by 2 into 3 by 3, etc. n by n, if matrix is in the form a, B, C, D. Okay, then A square, B square, C square, D square, and A cube, B cube, C cube, D cube. Then select the second row and take second minus first, third minus second, etc. The last minus first. Okay, so that you will be getting the answer like that. So again, I am just telling for 2 by 2, 3 by 3, etc. n by n matrices, if matrix is in the form, okay, A, B, C, D, then A square, B square, C square, D square, then A cube, B cube, C cube, D cube, etc. means you can select the second row, take second minus first, third minus second, etc. Last minus first. Okay, so that you will be getting the answer. Next, we are going to discuss about our inverse of a matrix. So let A is a matrix general form Aij be an n by n matrix. Then what is about that minor? Minor of an element Aij is denoted by capital Mij and is defined as Mij equal to n minus 1th order determinant. Cofactor of an element Aij is denoted by capital Aij and is defined as Aij is equal to minus 1 whole to the power I plus j into your minor. Minor is Mij. Then consider the matrix which is A, it is given. First row 1, 1, 2, second row 2, 3, 4, and third row 4, 7, minus 2. So consider your second row. The second element, that is A22, is 3 here. The minor of A22 is 1, 2. That is, you just leave that row belongs to that element and column belongs to that element. Remaining, you select 1, 2, 4, minus 2. That is your minor. Okay. Then you apply normal evaluation part. 1 into minus 2, it is minus 2. This one minus 4 into 2. So minus 2 minus 8 will be minus 10. Okay. This is a minor of your A22 entry 3. Then cofactor means this minus 10 can be multiplied with the position, that is here actually plus minus plus, then minus plus minus. So we are just multiplying that minus 1 to the power 2 power, that is A22 is there, no? So I is 2, J is 2, that is I plus j can be replaced as 2 plus 2. So minus 1 whole to the power 2 plus 2 multiplied by with your minor minus 10. So the answer is minus 10. Then invertible matrix. So a matrix A is said to be invertible if we can find some other matrix B such that AB equal to BA is equal to I. Then B is called the inverse of matrix A. So a matrix A is said to be invertible if we can find some other matrix B such that AB equal to BA, which is equal to I, then B is called the inverse of a matrix A. So some terms will be getting B is equal to A inverse. Okay, you just multiply with your identity term you will be getting. Then singular matrix, a matrix is said to be singular if determinant A equal to 0. Okay, so a matrix is said to be singular if determinant A equal to 0. Non-singular, if determinant A is not equal to 0, then the matrix is said to be non-singular. Okay, then A inverse formula, A inverse equal to adjoint of A divided by determinant of A. So adjoint of A equal to, you can keep this adjoint of A one side, bring this determinant A to other side. So you'll be getting adjoint of A equal to determinant of A into A inverse. Now you multiply A on both sides. So A into adjoint of A equal to A into determinant of A into A inverse. So A into adjoint of A equal to this A into A inverse can be written as I, identity matrix. Okay. So determinant A into I you will be getting. So which is equal to adjoint of A into I. Okay, so determinant A into I is called an adjoint of A into A. So A inverse is adjoint of A by determinant of A. Now, if you need other procedure, you can take inverse. Okay, so after taking the inverse also, you'll be getting same result. You should remember A into A inverse equal to I. Next it is, let A be an n by n matrix. We know that adjoint of A equal to determinant A into A inverse as per the formula of inverse. Then you are taking determinant. So determinant of adjoint of A equal to determinant of A into A inverse. Okay, you are using this property. Actually, determinant of Ka means, because determinant A is a constant value, no? So determinant Ka means we can write K to the power n into determinant A. As per the result we have discussed previously, no? You are going to use now. So you consider this determinant A as your K term. So you will be getting determinant to the power n into determinant of A inverse. Okay. So modulus of adjoint of A is modulus of A to the power n minus 1. If the base is same, we can add the powers, no? So determinant A to the power n minus 1. Next, replacing A by adjoint of A in the above result, you will be getting adjoint of this A can be replaced by adjoint of A. So adjoint of A, which is equal to adjoint of A to the power n minus 1. Okay. So this adjoint of A result we already know, no? This A modulus of, that is determinant of A to the power n minus 1 to the power n minus 1. So determinant of adjoint of A, which is equal to determinant of A to the power n minus 1 the whole square. Okay. So in a similar way, you are extending to that adjoint of A. Okay, that means determinant A to the power n minus 1 whole cube and so on. So the next we know that A into adjoint of A equal to determinant of A into I, know the result. So you just replace A by adjoint of A. So you will be getting adjoint of A into adjoint of A, which is equal to determinant of adjoint of A into I. So the adjoint of that adjoint result, no, you will be replacing the determinant A in, to the power n minus 1 result. So finally, you will be getting the result like that. Determinant A into I into adjoint of A, which is equal to determinant A to the power n minus 1 into A. So we are continuing this result to get the term adjoint of A equal to determinant A to the power n minus 2 into A. One result. Okay. So you have to remember all these results. While solving the problem, you will be using these results. The next, a matrix A is said to be orthogonal if A transpose equal to A inverse. Okay. So if A is an orthogonal matrix, then A inverse and A transpose are also orthogonal matrices. For the matrix M, you will be getting, it is a 3 by 5, 4 by 5 as a first row, second row x 3 by 5. such that M transpose equal to M inverse, the value of X they will be asking. So normal calculation method you just apply, you will be getting the answer. X is minus 4 by 5. It's the normal method. Next, if A is an orthogonal matrix, then its rows and columns are pairwise orthogonal. But inverse of the statement may or may not be true. If rows and columns of a matrix are pairwise orthogonal, then the matrix may or may not be orthogonal. That you have to remember. Next, if A is equal to Aij of order, that is, it's a 5 by 5 matrix such that Aij is I minus 1 for all I and j, and Aij is I square minus j square for all I and j. Find A inverse in each case. So first you represent your first subdivision. Aij is I minus j. Then Aji will be j minus I. That is minus of I minus j, which is equal to minus of Aij. Therefore, Aji equal to minus Aij. Okay. So therefore, A is a skew symmetric matrix. That means A transpose equal to minus A. So determinant of A transpose equal to determinant of minus A. You can use this property. Determinant Ka equal to K power n into determinant A. No, here in the place of K will be having minus 1. So minus 1 whole power 5. Okay. Because of order 5, 5 by 5 matrix. Minus 1 whole power 5 into determinant A. Excuse me. Therefore, determinant of A transpose equal to minus 1 into determinant A. So determinant A is minus determinant A, because as per the property determinant A and transpose of determinant A both are same, no? So instead of determinant of A transpose, we can replace determinant A itself. Then you combine the steps. That is determinant A plus determinant A is equal to 0. So twice of determinant A equal to 0, which implies determinant A is 0. Therefore, A inverse does not exist. So the note, inverse of any odd order skew symmetric matrix does not exist. Reason, since every odd order skew symmetric matrix is singular. Okay, that is determinant A is 0. Then inverse of even order skew symmetric matrix exists. Reason, since every even order skew symmetric matrix is non-singular. Okay, that is determinant A is not equal to 0. So the next subdivision to it is A matrix. It is given 0 minus 3, second row 3 0. This is of order 2 by 2. Okay, then A transpose 0 3 and minus 3 0. Okay, which is equal to minus of 0 minus 3 3 minus 0. That is A transpose is minus A. Okay, so determinant A equal to 0 minus of minus 9. So it becomes plus 9. So it is 3 square. So the determinant of even order skew symmetric matrix is a perfect square. If I throw jth column element of a matrix is in the form Aij is I to the power n minus j to the power n, where n greater than 0, the corresponding matrix is always skew symmetric. Okay. So if x and y are two non-zero matrices, this is the gate problem. If x and y are not, two non-zero matrices of the same order such that xy equal to 0 of order n by n, then the choices are given. The first choice, determinant x not equal to 0, determinant y 0. And B choice, determinant x 0, determinant y not equal to 0. C choice, both are not equal to 0. Then D choice, it is determinant x 0, determinant y 0. Both are 0 and xy is also 0. So they take the determinant on both sides. We just consider xy which is equal to 0 in the question. You should take determinant. So determinant xy is 0. As per the property, you know that determinant x into determinant y, which is equal to 0. That means either determinant x 0 or determinant y 0, or both determinant x and determinant y 0. Okay. Therefore, this is the correct option. Determinant x and determinant y is 0. The next They're continuing some expansions, okay, explanations, but it is enough to you. Next, the problem: if A, B, C, D, E, F, G are non-singular matrices of the same order such that some C, E, D, B, G, A, F, which is equal to identity matrix I, then B inverse. They asked to find B inverse. Okay, so they asked to find B inverse only, no. So B term. So first it starts with C. So you multiply C inverse on both sides. So C inverse C, E, D, B, G, A, F, which is equal to the right hand side also C inverse I. So C inverse C means it is I, no. So I into E, D, B, G, A, F, the remaining terms, okay, which is equal to C inverse. Next it starts with E. You cancel both the I's, okay. So remaining terms will be getting, it starts with E. So you just again multiply E inverse on both sides. Okay. Then it starts with D. So again you multiply D inverse on both sides. Okay. Now you will be getting D inverse, E inverse, C inverse. Okay. In the right hand side. Now you just from the right. Okay, first we just multiply with the left convex terms. Now we just apply the right multiplication. So F inverse, because F term is there, we multiply F inverse. Okay, the post multiplication, pre multiplication and the post multiplication. So F inverse, it is I, then you cancel the term. Similarly A, the next term it is A, no, so you multiply A inverse. In a similar way, you multiply G. Okay, G inverse to cancel the term. So you'll be getting B is equal to this. Therefore, B inverse, you can take whole inverse. That is G, A, F, C, E, D. This is the answer. Because AB, the whole inverse means B inverse into A inverse. That is the result we have applied here. So the answer of B inverse is G, A, F, C, E, D. This is the answer. In a shortcut way, you convert B as B inverse, you will be getting GAF, GAF, CED. The remaining terms, you write it as your answer. Okay, this is the shortcut way. The next problem: so some k is a positive real number and let A is a matrix which is given 2k minus 1, 2 root of k and 2 root of k is the first row. Second row 2 root of k, 1 and minus 2k. Then as well as the third row it's minus 2 root k, 2k and minus 1. Similarly the B matrix are given with the k elements. So find determinant adjoint of B and determinant adjoint of A. Third subdivision, determinant adjoint of A is some value 10 to the power minus 6. What is the value of K they are asking? Okay. So first you need to find determinant adjoint of B. That means you know it is determinant B to the power n minus 1. Okay. So but determinant of odd order skew symmetric matrix is 0. No, we have studied, no. So the answer is 0. Okay, so determinant adjoint of A equal to determinant A to the power n minus 1, which is equal to, here n is 8, no, so determinant A to the power 8 minus 1, which is determinant, yeah, it's not 8, it's 3, like, okay, because it is a 3 by 3 matrix, so it is 3. So determinant A to the power 3 minus 1, it is determinant A square. Okay, call this as some equation number 1. Then determinant A, it is given, no, already A matrix given. We need to take determinant on both sides. We'll be getting determinant A equal to 2k minus 1, 2 root k, 2 root k, etc. The remaining elements. Apply the row operations. R2 goes to R2 plus R3. Okay, to make the maximum number of elements to be 0. Okay, for our expansion of our determinant purpose. Then you can apply the column operation. C2 goes to C2 plus C3. So the remaining entries in your determinant is minus of, after that you expand, minus of minus 1 plus 2k into 2k minus 1 the whole square plus 8k. You will be getting the terms like that. Then it's a normal calculation part only. You can apply a minus b the whole square to expand the terms. Then you simplify. So you just call it as equation number 2. Now from equation 1 and 2, or you substitute this in the previous equation, you will be getting determinant of 2k plus 1 the whole cube the whole square, which is equal to 2k plus 1 to the power 6. Okay, then you combine these terms, you will be getting the answer. Next, third solution, determinant of adjoint of A is 10 to the power some 6. So 2k, adjoint of A, we got it now 2k plus 1 to the power 6, which is equal to 10 to the power 6. Okay, then you combine, just simplify the terms. You will be getting 2k equal to 9. So k is 9 by 2. These are all the normal calculation part. Okay. So if A, B, C, D are non-singular matrices of the same order, such that A, B, C, D equal to I, then B inverse is actually A, B, C, D, which is equal to I means you just B equal to, first you write C, D, then you write A. So C, D, A, which is the answer. Next, find the inverse of the following matrices. So A is equal to, first row 1, 0, minus 1, second row it is 2, 1, minus 1, then 2, 3, 2. So three problems are given for to find the inverse. You know that A inverse equal to adjoint of A by determinant of A method, no? So A is equal to the given matrix. Then you write the formula A inverse equal to adjoint of A by determinant A. Then determinant A is a 3 by 3 matrix and it is having a 0 terms. You can directly apply the expansion term. Okay, so that you will be getting the answer 1. Then adjoint of A. So 2, 1, minus 1. Likewise, you have to write. Or you can use the normal method. Okay, because it will be taking some time. Yeah, you can use the normal method. First, you find the minus and then cofactors. Then you will be getting your adjoint of A, this one. Okay, then you divide. You will be getting the answer. A inverse is adjoint of A by determinant of A value. So select the middle, or you can select that one. Select the middle row, middle element and move in anti-clockwise direction to complete one cycle. The corresponding element will be returned in the first column separately. Okay, so first select the middle row and middle element. So select the middle row, middle element, that is 1. Okay, then move in anti-clockwise direction to complete one cycle. The corresponding element will be returned in the first column separately. Okay, so you can apply the procedure. So select the third row middle element of moving the same anti-clockwise direction to complete one cycle. So the corresponding element will be returned in the second column separately. So repeated the same process with first row also. So copy the first column as a last column and find determinant of smallest matrices. Okay, so the procedure it is. So it will be taking some time. So you can apply the normal, minor and cofactor method. Okay, that will be easy compared to this method. So the procedure of 2 by 2, it is A inverse equal to same adjoint of A by determinant A only. Then given an orthogonal matrix A is equal to some matrix which is given, then they ask that what is A transpose inverse. So orthogonal means A transpose equal to I. That is the result. You know whether the matrix is said to be orthogonal, then it satisfies the condition A transpose equal to I. So A transpose inverse, we are taking inverse on both sides. So A transpose inverse equal to I inverse. But inverse adjoint of identity matrix is the identity matrix only, no? So A transpose inverse is I only. Next question, find the inverse of A. It is in trigonometry terms. Yes, actually A is an orthogonal matrix. So A inverse equal to A transpose. Okay. Next, it is a rank of a matrix. A submatrix. What is that to be actually submatrix? A matrix obtained by deleting some rows or columns or both is called as submatrix. Example, you consider a matrix which is 1, 2, 3, 4, 5, 6 and 1 minus 1, 0. Just you can delete that. You consider only 1, 2, 4, 5. Okay, you just delete the third column and the third row. Then it will be said to be a submatrix. Okay, like that you have to write. Then these are all the possible submatrices B2 and B3, etc. Then minor, the determinant of square submatrix is called its minus. Okay, the determinant B1, 1, 2, 4, 5 means 5 minus it, which is minus 3. These are all the minus. So the rank, if the determinant of highest possible square matrix is not equal to 0, then the order of the determinant is called rank of matrix. So if the determinant of highest possible square matrix is not equal to 0, then the order of the determinant is called the rank of the matrix. So find the rank of the matrix. It is a 3 by 4 matrix, 3 rows, 4 columns. You consider one 3 by 3 matrix, any 3 by 3 matrix from the above matrix. Then you find the determinant value which is equal to 0. Okay. Similarly, you can find the other 3 by 3 matrix which is not equal to 0. So at least one 3 by 3 matrix is not equal to 0 here. Therefore, the rank of that matrix is the order of that not equal to 0 term. So it is 3. Therefore, that matrix rank is 3 here. Okay. This is one way. The other way is row echelon form. A matrix A is said to be in row echelon form if and only if 0 rows should occupy the last rows if any. The number of zeros before a non-zero element of each row is less than number of such zeros before a non-zero element of the next row. Okay, so I'm repeating the row echelon form. A matrix A is said to be in row echelon form if and only if 0 rows should occupy the last rows if any. The number of zeros before a non-zero element of each row is less than number of such zeros before a non-zero element of the next row. So just example, we'll be having a matrix of order 6 by 6. Okay. The rank of row echelon form matrix is equal to number of non-zero rows. That is rank of A is for linearly independent row or to reduce any matrix into row echelon form, we should use only row operations. So every upper triangular matrix is in the row echelon form, but every row echelon form will not be an upper triangular matrix. The next, just to see the example 1, A it is 1, 2, 3, 0, minus 4, 2. That is that upper triangular matrix. Okay. So A is in the row echelon form. Here it's not an upper triangular matrix, but it is in the row echelon form. Okay. So the column echelon form, a matrix A is said to be in column echelon form if and only if 0 columns should occupy the last columns, if any. The number of zeros above a non-zero element of each column is less than the number of zeros above non-zero element of the next column. So consider the matrix A. It is 0. First you just see the column wise 0, 1, 1, 1, 1, 1. Similarly 0, 0, 2, 2, 2, etc. Then 0, 0, 0, 3, 3, etc. Okay. So note rank of a matrix is column echelon form is equal to number of non-zero columns. Okay. So here rank is 4. Number of non-zero columns. So to reduce any matrix into column echelon form, we should use only column operations. So every lower triangular matrix will be in column echelon form, but every column echelon form will not be a lower triangular matrix. Okay, then exercise or example 1 column. First row is 1, 0, 0, second row 3, 5, 0, and third row is 9, 4, 5. The lower triangular matrix is in the column echelon form. Similarly, the next example. Okay. The next, consider the matrix A. We will be giving some matrices. In the row echelon form, you just use only the row operations. It is R2 goes to R2 minus 2R1. Then R3 goes to R3 minus R1. You should make the elements to be 0. Okay, for that purpose only you are using the row operations. So after that, you will be getting 1, 0, 0, 3, 7, 0. Then minus 2, 8, 0. That is, you will be getting. Okay, the upper triangular matrix of the form. So it is the rank of A is 2. Then column echelon form, you can use only the column operations, okay, to make the terms matrices to be of the zero. That is here actually any one of the column is zero, no? So that rank of A is 2. So the rank of matrix is number of non-zero rows and number of non-zero columns. Okay. After applying either its row echelon form or column echelon form, you will be checking that number of non-zero rows and number of non-zero columns. That should be your rank of a particular matrix. Okay. Next, A matrix, it is given A inverse, they ask to find that is adjoint of A by determinant of A, no? The same procedure, okay? So let's go through each one. Students, am I audible? I lost my connection, it seems. Am I audible? Yeah, okay. So we are just discussing about the rank. Have you followed that rank part? So I don't know when I lost the connection part. That's why I'm asking. So yeah, I'm just continuing the class now. I'm discussing the rank now. Whether the screen is visible to you now? We are just discussing about the results of the rank of a matrix. Have you followed this? Yes. Okay. Thank you. So these are all the results of your rank. Okay. These results you have to remember. Then next problem, if A is Aij of order m by n such that Aij is I dot j for all ij, then what is the rank of A, it is asking. So it is a general matrix, you have to write is 1, 2, 3 to n, then 2, 4, 6 to the power 2n, etc. So to find the rank, convert the matrix into row echelon form. Okay, that is only the best way. You always convert the matrix into row echelon form by using only the row operations. Okay, so after using the row operations, you will be getting the matrix in terms of zeros. No, now you just consider the non-zero row, the number of non-zero rows. Here actually one, the first row alone. So the rank of that particular matrix is 1. Okay, this is the answer. So in a similar way, they'll be asking that problem 3. The rank of 5 by 6 matrix Q is 4. Then which of the following statement is true? Q will have 4 linearly independent rows and 4 linearly independent columns. Q will have 4 linearly independent rows and 5 linearly independent columns. Then Q transpose is invertible and Q transpose Q is invertible. Okay. So you just find the rank of Q 5 by 6. It is 4. So 4 non-zero rows or columns. So option A, option B. Okay, we'll be having Q will have 4 linearly independent rows and 4 linearly independent columns. So answer is option A. Because of rank 4. Okay, so you just have that 4 non-zero rows or columns only will be having your options. No, so 4 linearly independent rows and 4 linearly independent columns. The next. So linearly dependent and linearly independent vectors. That means the two vectors x1 and x2 are linearly dependent if one vector is expressed as multiple of the other vector. Okay. So two vectors x1 and x2 are linearly dependent. That is one vector is expressed as multiple of the other vector. So x1 and x2 same directional vectors. Example, x1 it is given 1 2 and x2 it is a column vector 3 6 x2. It is 3 into 1 by 2. No, it can be written as the multiple of the other vector. So it is called a linearly dependent vector. Next, two vectors x1 and x2 are linearly independent if and only if it is not possible to express one vector as the multiple of the other vector. Okay, example x1 it is 1 2, x2 it is 3 4. No, we cannot express in the form of the so we cannot express it in the form of your linearly that is a so we cannot express in the form of your product of the other vector. No, okay, multiple of the other vector. So we just saying that this is linearly independent. So the linearly dependent vectors, a set of r n vectors x1 x2 etc xr acts are said to be linearly dependent if there exist or scalars k1 k2 etc kr such that k1 x1 plus k2 x2 plus etc plus kr xr equal to 0 where k1 k2 etc kr are not all 0. Okay, at least one k value is non-zero. Okay, this is called a linearly dependent vectors. Then linearly independent vectors, this one, a set of or n vectors x1, x2, etc. xr are said to be linearly independent if there exists a scalar k1, k2, etc. kr such that k1 x1 plus k2 x2 plus etc. kr xr equal to 0, all zeros. Okay, that is the difference between the linearly dependent vectors and linearly independent vectors. The next criteria for linearly independent and linearly dependent. If rank of A, that is number of given vectors and determinant A not equal to 0, then the given vectors are said to be linearly independent. Okay, you have to remember the rank of A is number of given vectors or that is determinant of A is not equal to 0, then the given vectors are said to be linearly independent. So consider the vectors x1, 1, 2, 2, then x2 it is 2, 1, 2, and 3 it is 2, 2, 1. The determinant A, you combine all the x1, x2, x3 vectors, you will be getting the determinant A value, which is not equal to 0. Therefore, it is linearly independent. Then if rank of A is less than number of given vectors or determinant A equal to 0, then the given vectors are said to be linearly dependent. Okay. So consider the example. 3 given vectors are there. You combine all these things to get your determinant A value, expand and check whether the determinant A is equal to 0. Okay. If it is not 0 means it is a linearly independent case. If it is equal to 0 means it is a linearly dependent case. Okay. Likewise, you have to identify that linearly dependency and linearly independency. Next, If the given vectors are linearly dependent, then any one of the vector can be expressed as linear combination of the other vectors. Okay. So if the given vectors are linearly independent, then it is not possible to write any one of the vector as the linear combination of the other vectors. Next, we just go to some eigenvectors and eigenvalues and eigenvectors problems, because linear algebra you will be having all these topics: determinants, rank, then eigenvalues and eigenvectors are all things in your syllabus. So we just move on to that part. 1 second, I'm just showing you the eigenvalues and eigenvectors. I think you'll be having an idea because you already studied in your engineering mathematics 1 paper, no? Okay, these things you have to. The non-homogeneous system of linear equations. Okay, that is it. Rank, it is important to you. The rank of the matrix A is 5 and nullity of the matrix is 3, then order of the matrix. They will be asking like that. Okay, you have to remember this formula. N of A, nullity formula. N of A equal to small n of A minus rank of A. That is 3 equal to n of A minus 5. That is n of A is 8. Okay. So the rank of the matrix is given and the nullity of the matrix is 3. Then the order of the matrix they will be asking. Actually, nullity means it is denoted by capital N of A, and it is defined as the difference between order of matrix and rank of matrix. So N of A equal to order of A minus rank of A. This is the formula. Have to remember. And so before that itself, they are all linearly dependency and independency only. So after that nullity, the non-homogeneous system of linear equations. Consider the following non-homogeneous system. Okay, this is the general form of your non-homogeneous system. So the procedure, you just write Ax equal to B. Just I am recalling, you have already known about these things. So Ax equal to B, A matrix, then X is a column matrix, then B it is a constant column matrix. So coefficient matrix into solution matrix, which is column matrix of constants. Okay, write it in the form. Then write the elements of matrix B in the last column of matrix A. The resulting matrix is called the augmented matrix. That is AB. Okay. So after writing the augmented matrix, you just convert that into row echelon form. Hence find the rank. Okay. So after getting the rank, if rank of A is less than rank of AB, that is R rank of AB is not equal to rank of A, the given system of equations have no solution. Okay, inconsistent. It is called inconsistent. If rank of AB, there is the augmented matrix rank, okay, which is equal to rank of A, the number of unknowns, which is equal to the number of unknowns, then the given system of equation have unique solution. If rank of AB is equal to rank of A, which is number of unknowns, which is less than number of unknowns, then the given system of equations have infinite number of solutions. So if the given system of equations have a solution that is unique or infinite, the solution can be found by reducing the matrix into row echelon form and by using the backward substitution. Okay, the variables x1, x2, etc. xn can be found. Backward substitution and all you already know, you have studied under your numerical methods paper. Okay, back substitution method, no? Gauss elimination, Gauss Jordan and all you have to remember. So if the total number of equations is less than the total number of variables, the given system of equations have infinite number of solutions. So these infinite number of solutions can be found by assigning the n minus or variables as arbitrary constants. Next, so we're just going to see about our homogeneous system. We are discussing the homogeneous. So these are all the based on your rank. Okay. Next, eigenvalues. So let A be an n by n matrix. Lambda is a scalar some constant. The matrix A minus lambda I is called a characteristic matrix, and determinant A minus lambda I is called a characteristic determinant or characteristic polynomial. Okay. So the roots of this characteristic determinant are called characteristic roots or eigenvalues, or the latent roots or proper values. Then eigenvector, if lambda is an eigenvalue of a matrix A, then there exists a non-zero vector x such that Ax equal to lambda x. Then the non-zero vector x is called as eigenvector. So Ax is lambda x. That is, you have to remember A minus lambda I into x equal to 0. It is a trivial solution, means determinant A minus lambda is not equal to 0. Infinite solution means it is determinant A minus lambda is equal to 0. Okay. So you consider the matrix a 2 by 2 matrix. Then you write it in the form Ax equal to B format. Okay. Then here non-zero vector, it is 1 1, no, so you just write 4 plus 2 2 plus 4, which is equal to 6 6, that is 6 into 1 1, that is lambda into x. You can write like this is the shortcut way. First you consider the 2 by 2 matrix, then you find the sum, it is 4 plus 2 2 plus 4, no, you will be getting 6 6. So that solution term is non-zero vector, means this is the procedure. Then you take 6 as a common term, so that is called your eigenvalue. The eigenvector should be 1 1. Next, so any point vector exists along the same vector will also be an eigenvector corresponding to the same eigenvalue. Okay, this is the terms you have to remember. Then sum 4 2 2 4, the same given. So 4 plus 2, that is 2 4. Then the solution is 1 2, which is equal to 4 plus 4 and 2 plus 8. How we are getting 4 plus 4? You are adding the diagonal terms, then 2 plus that value. Okay, the first starting value, 2 plus 8. So 8, 10 you will be getting. So 2 into 4, 5, which is not same. Okay, this is the other procedure. So x is 1, 2 is not same. That is, if that solution vector both are same, means you can apply the first method. Here 1 1 is a non-zero vector as well as same. Okay, if both are different, 1 2 some different value, means you have to apply this procedure. Then find the eigenvalue and eigenvector of 3 4 4 minus 3. So symmetric matrix. This is a symmetric matrix. That means determinant A minus lambda I equal to 0. Then you find your normal procedure. You have to apply that expansion of your determinant. No, you just apply that procedure to get your lambda eigenvalue as well as your eigenvectors. You are replacing terms in your A minus lambda into x term. No, after that replace lambda equal to some constant, you will be getting some eigenvector. The same procedure you have studied in your syllabus. No, you can apply that method for a symmetric matrix type. Then the eigenvectors corresponding to different eigenvalues of a real symmetric matrix are always orthogonal. If the eigenvector corresponding to different eigenvalues of any square matrix are always linearly independent. Okay, so you just remember the result. So consider the matrix A 2 3 0 2. So lambda here actually it is 2 2, repeated twice. So when lambda 2 means we will be getting A minus lambda into x equal to 0. So the eigenvalues are repeated twice, means you have to apply this procedure. Okay. You consider some constant C for your x1. You have to assign your vector. Okay. One of your eigenvector to be a constant, and that constant should not be equal to 0. Like that you have to assign. Then you apply the procedure, you will be getting the answer. So if some of the eigenvalue of your matrix are repeated, then the eigenvectors corresponding to repeated eigenvalues may be linearly independent or linearly dependent. So if an eigenvalue lambda is repeated n times, the eigenvectors corresponding to repeated eigenvalues are always linearly independent, which are given by this P is n minus r. So the number of unknowns or variables, that is your n. Then r means it is rank of A minus lambda I term. So the properties of eigenvalues and eigenvectors, sum of eigenvalues is equal to trace of a matrix. Sum of eigenvalues is equal to trace of a matrix. The next, the eigenvalues of A and the row inverse of A P are same, where actually sorry, P inverse AP. P is a non-singular matrix. Okay, P inverse AP and the eigenvalue of A both are same. The eigenvalues of real symmetric matrix are real. The eigenvalues of skew symmetric matrix are purely imaginary or 0. The eigenvalues of orthogonal matrix are of unit modules, that is plus or minus 1. So if lambda is an eigenvalue of an orthogonal matrix, then 1 minus 1 by lambda is also one of its eigenvalue. So if lambda is an eigenvalue of a matrix A, then k lambda is an eigenvalue of Ka. 1 by lambda is also an eigenvalue of A inverse. Okay, so these are all the results you have to remember. Then problem, some A it is given, they ask to find it that eigenvalues, okay, for this problem. So trace of A, you need to find the trace of A, that is sum of the diagonal elements. Okay, you just add all these things, then you equate and you try to find your eigenvalues. So eigenvectors of a 2 by 2 matrix are given, means you have to take that eigenvalue, that is lambda 1 8, lambda 2 4, then mu1 it is 1 1, mu2 it is 1 some minus 1. Okay, then the matrix is 6 2 2 6. So you have to apply that A minus lambda into x equal to 0. This is only the prescribed method for to find the eigenvalues and eigenvectors. Okay, the remaining and all you have studied already. There is no new thing to you. Everything you have studied about eigenvalues and eigenvectors. Okay, to find the eigenvectors corresponding to non-repeated eigenvalue of a matrix, we can just proceed. Select the first two rows. Start from the first row middle number and move in anti-clockwise direction to complete one cycle. We already discussed, the same procedure we are going to apply here also. So if any element exists in the main diagonal while we are moving in anti-clockwise direction, then the eigenvalue should be subtracted from the corresponding diagonal element. Okay, these elements will be returned separately in row wise. So repeat the same procedure with the second row also and find eigenvectors. So the next one, the last one, is the Cayley-Hamilton theorem. Every square matrix satisfies its own characteristic equation. That is a Cayley-Hamilton theorem. Every square matrix satisfies its own characteristic equation. So you need to find the characteristic equation. Then you replace A equal to lambda. You will be getting that equation. Okay. So from that equation, you need to find your inverse term that already you studied in your portion syllabus. Okay. So we just move on to our next topic. Actually, you'll be having a three topics: linear algebra, calculus, and differential equations. So then we just move on to our calculus topic. Limits, the topics under calculus are limits and continuity, differentiation, definite integral, improper integral, partial differentiation, multiple integrals, vector differentiation, vector integration, and Fourier series. Okay. So calculus is defined as science acceleration, retardation, and variation. The function, so the relation between two sets A and B, if for all uh, belongs to, that is A, there exists a unique, if for all x belongs to A. You just consider one element x which belongs to A, there exists a unique element y belongs to B, such that f of x is equal to y or y equal to f of x. This is called a function. So the function, there are types of functions are there. It is explicit function. So dependent variable with independent variables. z equal to f of x1, x2, etc. xn. Z is called a dependent variable and x1, x2, etc. xn called independent variable. Then implicit function phi of z comma x1, x2, etc. xn, which is equal to constant, some constant c. Then composite function, if z equal to f of xy more than one function, one variable, okay, where x is equal to phi of t and y is equal to psi of t, that is z is a function of same some function actually more than one function with more than one variable, then it is said to be a composite function. Some special function, this even function. If you are replacing x is equal to minus x, okay, after replacing that also you will be getting your original function, means that will be your even function. So after replacing x equal to minus x, you will be getting negative of that function, means that is your odd function. The modulus function, sometimes it will be calling your rectangular function, okay, more than one function with different types of intervals, that is called a modulus function or a rectangular type of function. The differentiation of the modulus of x is modulus of x by x for x not equal to 0. The next, it is a step function or greatest integer function. F of x is x, which is n, where belongs to z, where n less than or equal to x less than or equal to n plus 1. Then some example it is given, you have to plot that point in your graph, okay, that is a graph representation terms. Then symmetric properties of the curve. Let f of xy is c be the equation of the curve. If f of x comma y contains only even powers of x, then f of minus x comma y equal to f of x comma y, then it is symmetric about y-axis. So if f of x comma y contains only even powers of y, that is f of x comma minus y equal to f of xy, then it is symmetric about x-axis. If f of xy equal to f of yx, then the curve is symmetric about y equal to x. Then the limit of a function. So let f of x be defined in deleted neighborhood of a belongs to R. Then L belongs to R is said to be a limit of f of x as x approaches a. If are given epsilon greater than 0, there exists a delta greater than 0, such that modulus of f of x minus L, which is less than epsilon, whenever modulus of x minus a, which is less than delta, okay. So limit extends to a of f of x equal to L. Then left hand limit and right hand limit. So left hand limit, when x less than a or x tends to a, then limit extends to a minus of f of x, which is equal to limit h tends to 0 of f of a minus h. That is called a left hand limit. Then right hand limit, when x greater than 0 or x tends to a, limit x tends to a plus of f of x equal to limit h tends to 0 of f of a plus h. A limit exists if and only if left hand limit equal to right hand limit. Indeterminate form, 0 by 0, infinity by infinity, 0 into infinity, infinity minus infinity, 0 to the power 0, 1 to the power infinity, and infinity power 0. So these are all the indeterminate form. That is after applying the limit, the function you will be getting as an indeterminate form, means you have to apply the L'Hospital's rule. That means limit extends to a of f dash of x by g dash of x. Okay, so this is called your L'Hospital's rule. This rule is applied until we are free from your indeterminate form. So the standard limit functions, limit extends to a of x to the power n minus a to the power n divided by x minus a, which is equal to n into a to the power n minus 1. The next limit extends to 0 of e to the power mx minus 1 by x, which is e. Limit extends to 0 of a power x minus 1 by x, that is log a to the base e. Limit extends to 0 of 1 plus ax to the power 1 by x, which is e to the power a. The limit extends to infinity of 1 plus a by x to the power x, which is e to the power a itself. Limit extends to 0 of sin x by x, which is 1. Or limit extends to 0 of tan x by x, also 1. Limit extends to infinity of sin x by x, it is 0. So just go through the results carefully. If the limit values are changing, the result also will be varying. Limit extends to 0 of sin mx by x, it is m. Limit extends to 0 of a power x plus b power x by 2 to the power 1 by x, that is square root of ab. limit extends to 0 of cos x plus a sin bx to the power 1 by x, that is e to the power ab. Limit extends to 0 of 1 minus cos ax by x square, which is equal to a square by 2. So these are all the results, standard limit functions. You have to remember the question is in the form, right? Directly you can apply the right hand side value as your answer. Next question. Limit extends to 0 of 1 minus cos 3x by x into sin 2x. So the solution, limit extends to 0 of this. If you are substituting, you will be getting it indeterminate form, so that you can apply the L'Hospital rule, f dash of x by g dash of x. So the differentiation of 1 minus cos 3x is 3 sin 3x. Differentiation of x sin 2x, it is uv method. So u dash v plus u into v dash. So sin 2x plus 2x into cos 2x. Now, uh, you just taking that limit extends to 0. Okay, again you will be getting the term, so again you are differentiating, you will be getting 9 cos 3. Again and again you are applying in L'Hospital's rule until you are free from your indeterminate form, until you will be getting some finite value. You have to apply your L'Hospital's rule. So this is the answer. So some shortcut way is given. Limit extends to 0 of 1 minus cos 3x by sin 2x, it is given, no? So you just write it in the form of divided by term. So sin 2x by x and 1 minus cos 3x by x square, so that you can apply your limit term. You will be getting the answer directly. The next, limit extends to pi by 2 of sin square 2x by x minus pi by 2 the whole square. That is, you just see that the x can be written as pi by 2 minus x, because the limit it is given pi by 2, no? So you just write pi by 2 minus x. Then you convert that pi by 2 minus x as a single term. So you apply the substitution method. You consider pi by 2 minus x as some variable t. Then you replace, so that you just replace your limit term. You will be getting the constant directly. So this is the answer. Next, limit extends to 0 of log x by cot x. Okay. So you have to apply your L'Hospital's rule. 1 by x by differentiation of cot x is minus cosecant square x. Then you just rearrange the form. Actually, cosecant square x means it will be 1 by sine square x. That 1 by sine square x can be written in the form of sine x by x into sine x. Okay, because we got the result of limit extends to 0 of sine x by x is 1, no? So already one negative sign is there. So minus 1 into limit extends to 0 of sine x. That is sine 0, it is 0. So that is multiplied by 0 means your answer is 0. Then limit extends to pi by 2 of tan x by log cos x. Again you have to apply your L'Hospital's rule. So you differentiate, then you rearrange the terms like your previous term. Secant square x means it will be 1 by cos square x. Okay. So after simplifying the term, you will be getting minus infinity. Okay, this is for answer. So pi by 2 sine 90 degree and cos 90 degree. Then limit extends to pi by 2 of tan x. The limit does not exist because the left hand limit is not equal to the right hand limit. So if left hand limit and right hand limit are same, then only your limit term will be existed. Okay, that you have to remember. The limit extends to 0 of sine x log x square. So that sin x can be written as 1 by cosecant x. So limit extends to 0 of log x square by cosecant x, which is equal to, it is an indeterminate form. So you differentiate, apply L'Hospital's rule. So after differentiating the terms, you just rearrange that. Again you apply cosecant x as 1 by sin x, cot x as 1 by tan x. Okay, then you will be getting the result as 0, because sin x by x it is 1, but tan 0 it is 0. So you multiply the term, you will be getting the answer. The next one, the same manner, you will be having your limit functions. Okay, have to apply the limit directly. If you are getting an indeterminate form, you can apply L'Hospital's rule. So until you will be getting one finite value. So many limit terms are there. The next form actually 1 to the power infinity form. That is limit extends to a of f of x to the power g of x means e to the power limit extends to a of g of x into f of x minus 1. Okay, this is the form. So limit extends to 0 of 1 minus sin x to the power 1 by sin x. That's a power function. That means e to the power limit extends to 0 of 1 by sin x into 1 minus sin x minus 1. So which is equal to e to the power minus 1. So answer is 1 by e. So the power terms you will be having means you have to apply this rule. E to the power limit extends to 0 of 1 by x square into cos x minus 1. Then you apply the limit term so that you will be getting the answer. Next it is actually a power x plus b power x by a minus b. That formula. So square root of ab. So a is 2, b is 8. So square root of 16 is 4. Next, limit x, 19th problem, limit extends to 0 of modulus of x by x. So first find left hand limit, it is minus 1, the right hand limit it is plus 1. So both are different, so the limit does not exist. So limit extends to a of x does not exist when a is an integer. Okay, if a is an integer means that x does not having a limit point. Because the left hand light and right hand light will not be same. Next, continuity of a function. So the continuity at a point, a function is said to be continuous at a point x is a if limit extends to a of f of x equal to f of e. Continuity in an interval, a function f of x is said to be continuous in a comma b if it satisfies the following three conditions. That is, f of x is continuous for all x belongs to ab, limit extends to a plus of f of x equal to f of a, then limit extends to b minus of f of x equal to f of b. Okay, example, f of x equal to x square minus 4 by x minus 2 if x not equal to 2 and 2 if x equal to 2. Okay, they ask to check the continuity. So at x is equal to 2, limit extends to 2 of f of x, which is equal to limit extends to 2 of the function, it is x square minus 4 by x minus 2, no, which is equal to limit extends to 2 of, you are differentiating the terms. Okay, you are applying the L'Hospital's rule. So 2x by 1, which is 4. So at x is 2, f of x is 2. So f of x is not continuous at x is equal to 2. In a similar way, you have just check that other terms too. Then it is a power function, no? So e to the power limit extends to 0 of 1 by x into 1 plus 3x minus 1. Then you apply the limit, you will be getting the answer. So f of x is continuous at x is equal to 0. Next. If f of x is it's a rectangular function, so every function with a different interval, okay, that is called a rectangular function. So you are checking in the same manner like your previous problem. So here f of x is discontinuous at x is equal to 1 by 2. Okay, we have to check its continuity by applying the limit. Next, differentiation. So a function f of x is said to be differentiable at a point x is equal to c if limit extends to c of f of x minus f of c by x minus c exists and finite. Okay, so it is represented by f dash of c. Then left hand derivative, limit h tends to 0 of f of c minus h minus f of c by minus h. Then a right hand derivative, limit h tends to 0 of f of c plus h minus f of c by h. The necessary condition for a function to be differentiable is left hand derivative equal to the right hand derivative. So f of x is modulus of x is not differentiable at x0. That means we need to find our left hand limit. Limit h tends to 0 of f of 0 minus h minus f of 0 by minus h. That is limit h tends to 0 of 1 minus h minus 0 by minus h, that is minus 1. Then right hand limit h tends to 0 of f of 0 plus h minus f of 0 by h, that is limit h tends to 0 of modulus of h minus 0 by h. Okay, that is what plus 1. So the left hand limit derivative is not equal to the right hand derivative. So it is not differentiable. Modulus of x minus a is not differentiable at x is equal to a, and modulus of ax plus b is not differentiable at x is equal to minus b by a. So f of x equal to modulus of x plus modulus of x plus 1. This modulus of x minus 2 is differentiable at x is equal to dash. Okay, this differentiable at x is equal to 1. Then f of x is modulus of x plus 1 be defined in the interval 0, 4. So then f of x is continuous and differentiable. So if f of x is modulus of x cube where x belongs to R, then f of x at x0 is twice differentiable but not thrice. Okay. Yeah, differentiating thrice means we'll be getting 0 at that point x0. Okay. Next. F of x modulus of x cube minus x cube where x greater than 0 and x less than 0, 0 is x are 0. Then just finding the left hand limit and right hand limit, both are equal, so this is continuous. Then left hand derivative and right hand derivative, both are 0, it is differentiable. Then f dash of x, they are differentiating the terms. Okay, first derivative, second derivative and third derivative. So if f of x is 2 plus x for x greater than or equal to 0 and 2 minus x if x less than 0, then f of x at x is equal to 0 is continuous but not differentiable. That means the left hand limit and right hand limit are equal, but the left hand derivative and the right hand derivative is not equal. That means it is continuous but not differentiable. Like that you have to write. So every differentiable function is a continuous function, but every continuous function is not differentiable. Next, mean value theorem and Rolle's theorem. So let f of x be defined in the interval a comma b such that it satisfies three conditions. F of x is continuous in the closed interval a comma b. F of x is differentiable in open interval a comma b, and f of a equal to f of b. Then 3 exists at least one point. Then there exists at least one point 3 belongs to a comma b such that f dash of 3 equal to 0. This is called a Rolle's theorem. Next, Lagrange's mean value theorem. Let f of x be defined in closed interval a comma b such that it satisfies two conditions. F of x is continuous in closed interval a b. F of x is differentiable function in open interval a comma b. Then there exists at least one point c in that open interval a b such that f dash of c equal to f of b minus f of a by b minus a. If f of x is defined in closed interval a comma a plus h such that f of x is continuous, f of x is differentiable, then some theta belongs to 0 comma 1 such that f of a plus h equal to f of a plus h into f dash of a plus theta h. That is theta is c minus a by c minus b. Okay, this is result also you have to remember. The mean value c for the function f of x is e power x into sin x minus cos x in the closed interval pi by 4 comma 5 pi by 4 is pi. The solution, you just find the function at the point f of pi by 4 and that at the point f of pi by 4 separately, and both are same. So f dash of x you need to find. Then f dash of c, actually e into 2 power c into sin c, which is 0, which implies c is 0 plus or minus pi plus or minus 2 pi etc. Therefore here the option is given pi, no, so you just take that answer is pi. The main value c for the function is pi. Next, the mean value c for the function f of x given some function in the closed interval 0 comma 4. So we need to find f of 0 and f of 4. Here both are some different value. Then f dash of x finding and f dash of c. which is equal to f of 4 minus f of 0 by 4 minus 0. That is the mean value theorem. So you simplify, you will be getting C is equal to some 2 plus or minus 2 by root 3. Okay, that is the answer you have to select. Next. So the value of zeta of f of b minus f of a, that is equal to b minus a into f dash of zeta for the function f of x equal to a x square plus bx plus c in the closed interval a comma b, that is b plus a by 2. So f dash of x actually 2ax plus b. Then f dash of zeta, it is a Lagrangian mean value theorem, no? F of b minus f of a by b minus a. So we are equating the terms. Then you need to find f of a and f of b separately. You replace all these terms in your function term. You just make some simplification and you keep zeta term alone one side, bring the remaining terms to other side. So that will be your answer. So zeta is b plus a by 2. Similarly, the mean value C for the function f of x is 3x square plus 5x plus 11. The interval 11 by 2 comma 16 by 2 is, so C is equal to 11 by 2 plus 16 by 2 by 2, which is 27 by 4. Okay, that is your answer. The function f of x is polynomial of degree 2, that is a quadratic, then C will be the average value. Okay, so you just remember, if the given function is polynomial of degree 2, that is a quadratic, then C will be the average value of the extreme value of the function in the given interval, that is C is a plus b by 2. So if f of x is defined in a particular closed interval a comma b. Then the next one, the value of theta belongs to open interval 0, comma 1 for the function f of x is log x to the base e in closed interval 1, comma e. Using an appropriate mean value theorem is f dash of x is equal to 1 by x, which implies f dash of c is 1 by c. Then f of 1, it is log 1 to the base e, value is 0. Then f of log e to the base e, that is 1. So using Lagrange's mean value theorem, 1 by c, that is f dash of c equal to f of b minus f of a by b minus a. That formula, no, you can replace all these terms. You just keep c equal to e minus 1. Therefore, theta is c minus a by b minus a, which is also you just replace, which belongs to that interval 0, comma 1. So the Lagrangian mean value theorem cannot be applied for f of x is x to the power 1 by 3 in closed interval minus 1, 1 because of f of x is not differentiable in minus 1, comma 1. Open interval minus 1, comma 1. Because it should satisfy the conditions, no, it is continuous in closed interval, it should differentiable. Then the third term, the derivative f dash of c is f of b minus f of a divided by b minus a, where c belongs to open interval a comma b. Then the explanation it is given, f dash of x is 1 by 3 into x to the power minus 2 by 3, which is 1 by 3 x to the power 2 by 3. So f of x is not differentiable at x0, because we are substituting x0, you'll be getting 1 by 0, it is an infinity. Okay, so f of 0 is 0, the left hand limit is 0, the right hand limit is 0. So it is continuous, but it is not differentiable. Okay. Then the Rolle's theorem cannot be applied for f of x is modulus of x plus 2 in minus 2 in the closed interval minus 2, comma 0. That means f of minus 2 is not equal to f of 0. That is, it is not continuous. Okay, so if any function which is not continuous means definitely it will not be differentiable one. Then next, if f dash of x is 1 by 5 minus x square and f of 0 is 1, then the lower and upper bounds of f of 1 are dash. So let f of x be defined in closed interval 0, comma 1. By the Lagrangian mean value theorem, the resistor C belongs to open interval 0, 1 such that f dash of C is f of 1 minus f of 0, that is f of b minus f of a. Here b is 1 and a is 0, by b minus a, that is 1 minus 0. Then you simplify, so f dash of C equal to f of 1 minus f of 0, the value is 1. So minimum of f dash of x is less than f dash of C, which is less than maximum of f dash of x, that is 0 less than or equal to x less than or equal to 1. Therefore, 1 by 5 is less than f of 1 minus 1, which is less than 1 by 4. This term, you just adding that minus 1. The middle term, you just bringing the left and right. So 1 plus 1 by 5, which is less than f of 1, which is less than 1 by 4 plus 1. Okay. Next it is Cauchy's mean value theorem. With two functions, you consider the two functions f of x and g of x be defined in a closed interval a comma b, such that they satisfies the condition f of x and g of x are continuous in closed interval ab, f of x and g of x are differentiable in open interval ab, and g dash of x is not equal to 0 for all x belongs to open interval ab. Then the resistor C belongs to open interval AB such that f dash of C by g dash of C, which is equal to f of b minus f of a divided by g of b minus g of a. This is your Cauchy's mean value theorem. So based on that, we will be asking questions. The mean value C for the function f of x is e power x and g of x is e power minus x in the closed interval 0, 1 is dash. So f dash of x is e power x here. F dash of c is e to the power c. So g dash of x is minus e power minus x and g dash of c is minus e power minus c. Similarly, we need to find the limit terms f of 0 and f of 1. Here f of 0 is 1 and f of 1 is e. Similarly, g of 0 is 1 and g of 1 is 1 by e. So we are substituting the formula f dash of c by g dash of c equal to f of b minus f of a by g of b minus g of a. No? So that you will be getting e power c by minus e power minus c, which is equal to e minus 1 by 1 by e minus 1. So minus e to the power 2c. We are bringing this denominator to the numerator. If the base is same, we can add the powers. After applying the constant, you will be getting minus e power 2c in the left hand side. The right hand side will simplify because in the denominator 1 by e minus 1 is there. No? So after simplifying the terms, you will be getting e minus 1 by 1 minus e into e. Therefore, e to the power 2c equal to e. Okay, because c is 1 by 2, which belongs to 0, 1.